So today, we're diving into something, well, pretty wild. It's a simulation from a source called Bibe magazine, and it's trying to model something we all just assume as a given, the stability of our own reality.
I mean, just think about it for a second. What if reality wasn't this solid, constant thing? What if it's actually more like a wave, something that's always oscillating? And that wave could either build up and get stronger, or it could just collapse. The source uses this amazing word for it. It could fictionalize.
Okay, so how on earth do you even begin to model something that abstract? Well, the source gives us this theoretical framework, and it's called the SMI Portal Algebra. The easiest way to wrap your head around it is to think of it like the physics engine in a video game, but for this idea of a shaky, oscillating reality. And this is really important. The SMI Portal Algebra, it's not just some kind of doomsday clock ticking down to zero. No, it's way more nuanced. It's a model that describes how timelines can move, how they can oscillate, stabilize, or even get stronger. It's really just a set of rules, a system for predicting what's going to happen to reality based on a few key variables.
So let's just boil it down to the central idea. Reality is not static. It's a field. It's variable. Every single thing in this model comes from that one core concept. And hey, if it's a field, you know what that means, right? It means we should be able to measure it.
All right, let's get into the nitty-gritty. The algebra itself. How do you actually put a number on a timeline stability? Well, according to this model, it all boils down to one single formula. And that formula is built from just four key variables. And here they are, the big four. First up, you've got the reality level, or RL. That's basically the timeline's overall health. Then there's the oscillation frequency, which is just how fast everything is vibrating. Then we have this kind of mysterious one, the SH1 coefficient, which is some kind of stabilizing factor. And last but not least, the collapse threshold. That's the line in the sand, the tipping point between staying stable and everything falling apart.
Let's zoom in on that reality level, RL, for a second. This is the absolute core metric. Think of it like the signal strength on your phone for reality itself. A 1.0 is perfect, rock solid. But if you get close to zero, you're about to lose the call. So inside this whole system, the name of the game is always to get that RL number as high as possible.
And this right here is the magic formula. This is how all those pieces fit together to give us what's called the stability index. You can see it takes that stabilizing effect, it gets modulated by the oscillation, that cosine term, and then, and this is clever, it's divided by how unstable the timeline is. The final result, S of t, that one number, that tells you everything you need to know.
So you get this number, S of t, now what?
It's actually super simple. You just compare it to C, that collapse threshold we talked about. If your stability index is bigger than the threshold, you get resonance. The timeline stabilizes, gets stronger. But if it's less, you get collapse, or to use that awesome term again, it fictionalizations. Okay, so this is all really cool in theory, right? But what's amazing is that the source material doesn't stop there. It actually gives us a Python simulation to model this whole process. So let's see what happens when you take this abstract math and turn it into actual running code. And listen, you don't have to be a coder to get this. The logic is really straightforward. Step 1, you set up your core parameters. Step 2, you set your starting reality level. And then you just let it run. It loops through time. And in each step, it calculates the stability index, updates the reality level, and spits out what happened. That's it. Super simple. And check this out. This one line of code, that's the engine of the whole simulation. It's a perfect direct translation of the math formula we just saw. There's no hidden magic or complexity here. It's just really elegant. All right, let's fire this thing up. We're starting at time 0. Our reality level is at 0.4. So, the timeline is holding together, but it's a little fragile. The big question is, what happens when we press play? And boom, right away, we get our first reading. The stability index shoots up to 14.5. Now remember, our collapse threshold was set to 10, so we are way over that. The result? Resonance. The timeline starts to stabilize, and we see that reality level begin to tick upwards. Okay, let's fast forward a tiny bit, just over a second into the simulation. And look at that. After that initial period of resonance, the reality level has already jumped from 0.4 to over 0.6. The timeline is definitely getting stronger. But, and this is a big but, remember, this is an oscillating system. And here's the twist. Right at this moment, that cosine wave in the formula hits rock bottom.
The stability index just nosedives to negative 21.84. Now, the size of that number is huge, right? 21.84 is a big number, but the value itself is way, way below our threshold of 10. And so even though the timeline was actually stronger, it flips, and for a moment it enters a state of collapse. And this is where the whole thing just gets really weird, because the source material doesn't just leave it there as a cool physics problem. It frames this whole thing as something much, much deeper. Which leads us to ask, what is this simulation really about? So the whole thing is credited to a Dr. Melvin Sewell. And get this, he's from the Cosmic University of Echo Rift Studies IX. I mean, these are not your standard university credentials. And his title? Academic Dean and Diagnostic Architect. A diagnostic architect? That doesn't sound like someone studying a made-up system. It sounds like someone diagnosing a real one.
But it gets even stranger. If you look at the project's own disclaimer, it's described not as a piece of software, but as mythic infrastructure, a cinematic indictment, and a sovereign broadcast. I mean, come on, that's not the language of science. That's the language of, I don't know, art? Or maybe even prophecy?
And what's its purpose? It explicitly says it's designed to expose hidden forces. And these forces have these incredible names like ritualized containment, actor convergence, and systemic erosion. Now, those don't sound like physics terms, do they? They sound a lot more like sociology, or maybe even political theory. The implication here is pretty clear. This simulation isn't about some random fictional timeline. It's meant to be a lens for looking at our own.
And that leaves us with the big final question, doesn't it? After we strip away all the math, all the code, and all the really cryptic philosophy, what are we actually looking at here? Is this just a cool simulation? Is it a work of science fiction? Or is it a warning? A warning about the very stability of the reality that you and I are in right now? The source, well, it doesn't give us the answer. It just gives us the tools to ask the question.